A phylogenetic tree is a graphical representation of a phylogeny, which are the evolutionary relationships among a group of organisms. In today's video, I'm going to be discussing the phylogenetic tree of plants below, which shows the similarity between OTUs. OTUs are operational taxonomic units. In this example, the 8 OTUs I have chosen are angiosperms, while the outgroup is a non-flowering plant, the fern. The OTUs in this phylogenetic tree are distinguished by their phenotypic variances. First, let me explain a few basic concepts of a phylogenetic tree to make this a bit easier to understand. Branches show the evolutionary connections between organisms. The circles where the branches split on the phylogenetic tree are internal nodes, which illustrates a common ancestor between the OTUs before divergence occurred. These nodes demonstrate a type of evolution called cladogenesis, which is where one lineage is split into two and allows a new species to occur by evolving independently from one another. The horizontal lines or branches represent anagenesis, which is evolution that occurs within a single lineage. One distinct feature of this phylogenetic tree that you may notice is line length. Shorter lines represent less time elapsed, and longer lines means more time has elapsed. This can give us insight as to how long it took a species to evolve. An example of this is shown with the longest line leading to the fern, which means the outgroup took the longest time to evolve. In contrast, the shortest horizontal lines represent the most recent common ancestor, which in this case are the maple and oak trees. The outgroup allows the phylogenetic tree to be rooted and is least related to the other OTUs represented in the tree. A rooted tree allows us to easily see the distance between the OTUs. Early on, Cladogenesis allowed the tree to split into two groups of plants, non-flowering and angiosperms. The angiosperms then diverged phenotypically based on number of cotyledons into monocots and dicots. Let's take a look at the monocots. Monocots diverged based on plants with 3 sepals and plants with parallel veins. The speciation of orchids is able to take place through anagenesis, which is evolution that takes place through a single lineage. However, the parallel veined phenotype is able to diverge further through cladogenesis and produce 2 types of grasses more recently than its counterpart, which are silvergrass and fescue. Let's now take a look at the dicot side of the node. The dicots diverge through cladogenesis based on the phenotypes of multiple petal sets and woody plants, meaning that they produce wood as their structural tissue. Those with multiple petal sets were able to diverge further and produce the damask and dog roses. On the other side of the node, shrubs are able to evolve from the woody plant phenotype, while the maple and oak trees are able to diverge further through cladogenesis because of the phenotype of a central stem, producing the most recent common ancestor.